I'd like to thank everyone for joining us. Welcome to today's CNCF webinar, Next Gen Data Protection for Next Gen Applications. I'm Libby Schultz, and I'll be moderating today's webinar. We would like to welcome our presenter today, Deepak Verma, Director of Product Strategy at Zerto. A few housekeeping items before we get started. During the webinar, you're not able to talk as an attendee. There's a Q&A box at the bottom of your screen, separate from the chat box. Please feel free to drop your questions in the Q&A box and we'll get to as many as we can at the end. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. And basically, please be respectful of all your fellow participants and presenters. Please also note that the recording and slides will be posted later today to the CNCF webinar page at www.cncf.io/webinars. With that, I will kick off today's presentation and hand it over to you.
Thanks, Libby. And thanks everyone for attending this session. So kind of a little background on what I'm going to talk through today. And it's pretty simple. I'll introduce who we are in a minute, but the genesis of this is that a lot of customers were asking us to develop something for containers and Kubernetes application protection. And rather than force fitting an existing product or a legacy product into cloud native applications, we took a different approach. And I'd say we learned a lot about cloud native applications along the way. But also, I think we can contribute a lot to the cloud native approach of designing applications. So what I wanted to share with you today was some of the data points that we gathered from the market, as well as how we converted those into design considerations for developing a new platform. A little bit about me first. I have a lot of years of experience in data protection by choice or lack of choice. I've been doing DR since Y2K days. My first job was at a bank preparing for the Y2K crisis that never happened, but involved a lot of DR testing of various operating systems at the time. Through the years, obviously, technology has changed and evolved and learned new technologies. In the recent years, I've focused quite a little bit on various cloud platforms, specifically public cloud platforms. And I'm a huge supporter of designing applications in a cloud native manner. I think it's the future of applications for us. As a side note, I'm an avid biker, road biker, and if there's one good thing that's come out of the quarantine because of the pandemic is I've got a lot of miles on my bike this year, and I've climbed almost more than 50 vertical miles. And if it weren't for the cold in Wisconsin, I think I would have increased. So that's been an achievement, a positive side out of the quarantine that we're all in. A little bit about Zerto, where I'm a director of product strategy, part of the product organization. So this means I talk to a lot of customers as well as interface with our engineers and product owners to really design our products to meet the requirements of our customers and really our customers' next gen applications so we can bring it to market. A little about Zerto, we just crossed our 11th year, actually 11th anniversary just last week. We have over 8,000 customers, and we provide a single platform for disaster recovery, backup, and recovery as well. And it's been primarily focused around VMs entirely. So we started out when VMs were a new thing, and customers were thinking about how am I going to protect my applications that I'm going to put on VMs. Now we're at a junction point as well, where there's an evolution happening in a lot of environments, and the same questions are being asked of us for cloud native applications, specifically around containers and Kubernetes applications. So this is what I'm sharing with you guys. To gather some of the data that we wanted for designing our own platform, one of the data sources that we had tapped on was Enterprise Strategy Group to actually run a survey for us across enterprises in the Americas. And the objectives of the survey were pretty simple. And by the way, these results are published on ESG's website. You can also get it from Zerto.com if you want to look at the full details, but I'll be going through just a few of the the highlights that are relevant for the design of our solution. So what we want to look at was first market adoption. Obviously, in this community, there's we're living and breathing containerized applications, Kubernetes, and all the various platforms associated with it on a daily basis. But we want to see what the penetration was in what I'll call traditional enterprise organizations. And also with that, understand what some of the challenges were, not just specific data protection, but beyond data protection. And along with that, it's been a change in looking at the persona from a standpoint of who's making the decisions, how are these applications being architected, how are they being brought into production, and who's responsible overall for the decision making. That was important for us. And then lastly, also looking at the features. What features will be important for an application that would, or platform that would provide a certain level of challenge reduction in this environment. So these are the four kind of areas that we were looking at from a high level. And a survey was done back in June of this year, and we had a good, healthy set of customers responding, about 334. It was primarily focused around North America, US and Canada, just for making it a quick turnaround time frame. And it was limited or scope narrowed down to folks, professionals who were responsible for application environments and strategies specific to do with containers, Kubernetes. And we got a good representation across both the size of customers, mid-market being, I believe 500 employees, or 500 to 1,000, as well as enterprise, which is greater than 1,000 employees. So we got a very good representation, both from size as well as from industry vertical. And again, you can look at the full results. So first thing was we wanted to see what is it that customers were using containers for. What type of applications were they running containers? Primarily because the adage out there is it's for stateless workloads, and that's how containers have really grown. But what we were pleasantly surprised to find is that quite a lot of stateful workloads were being protected. If you look at the survey results, databases was a top one. If you consider migration of existing applications to cloud, we know that if we just go with the assumption that half of those are stateful, there's a considerable portion there. Web applications, primarily stateless, but transactional applications, as well as CI/CD pipelines, you're going to find state in there as well. And I particularly like the any application being deployed, because I've heard that from a lot of customers I've talked to, where any future applications, they're building it in a cloud native manner, and some will have state and some will be stateless. So from our design perspective, what that meant for us is that we've seen an evolution where more state is being put inside a container. So more persistence is being put inside containers applications. And we believe, also speaking from personal experience both as a user, is that this is primarily to avoid lock-in. If I'm designing an application and I have to rely on state coming from VMs, now those VMs are essentially part of my application. I have to worry about that aspect. I can go with the assumption that another group takes care of that and ensures that those applications are always available, but that really breaks the architecture of my application. The same thing kind of extends to PaaS and SaaS services that are available specifically from a lot of the public cloud vendors. They always have flavors that are associated with that specific cloud platform, and it makes it hard to be flexible in movement. So if I'm running an application on one cloud platform and I've really incorporated into specific PaaS and SaaS services from that vendor, and I want to switch, lift and shift my application or expand into another cloud vendor, maybe I'm getting a better deal, or maybe I have better services that they're offering on that platform. If I've integrated with PaaS and SaaS, that makes it a little difficult. Whereas if I've put state within my cloud native application, within the containers, I can move both my stateless and my stateful to the different cloud platforms. So we think flexibility and that avoiding that lock-in is another driver. So what this meant for us is really looking at protecting and recovering, as well as providing all the use cases for both the stateful components as well as the stateless components. If we purely just focused on the stateful components, then the challenge would have been that the stateless entities that you need would still need to be brought up, and especially when it comes to recovery times, that can start becoming a challenge. So that was a very critical design component for us, and I feel that this is a way, especially in the upcoming year, where a lot of applications will evolve to having both state and stateful as part of the application set. So obviously, being primarily focused in the recovery area of the industry, one important question that comes to top of mind is, well, what does recovery mean for these customers? What are RPOs and what are RTOs that they want to achieve? So the question we asked is, what's your RPO tolerance for these containerized applications? And I was frankly surprised, because throughout my career, I've seen different versions and types of this survey, and two things kind of hit me immediately. One was the fact that the entire graph has shifted left. What I mean by that is, this survey was done 3 years ago, just as recent as 3 years ago, a lot of the application respondents would have been okay with 4 hours, 8 hours, even 24 hours. But we see that now we've essentially narrowed the scope and really limited the field of loss to just minutes, where the estimated mean, the average running mean for the survey results was about 22 minutes. So if we go with that, basically it means is that most applications are not willing to accept beyond 22 minutes of loss. There's what from our design perspective, right off the bat, to us, what that means is anything that is agent-based, anything that streams data from the application to get a copy for protection purposes, completely is out of the equation. It's just way too short of a time frame. And it really puts snapshot-based approaches into question as well, because I was doing a little bit of quick math before the presentation here. And if I'm doing snapshots every 22 minutes, I found that I would need about 65 snapshots a day to maintain a day's worth of checkpoints. And if I have, say, 50 applications with 50 persistent volumes behind them, we're looking at about 3,272 snapshots that need to be managed. And that's just for a day for 50 persistent volumes. Multiply that with business tolerance, business governance requirements. That becomes a nightmare, not just from a management standpoint, but also from a scaling standpoint. And systems that are providing snapshot-based approaches really tackle that. So the second question, obviously, again, being very resilient focused, is looking at the recovery times. So for those who are not from the DR industry, what that really means is, how long can you tolerate from a loss point to bring an application up? And again, very interesting, everything had kind of shifted left in terms of the scale, and with the estimated mean being around 2.8 hours. So when you look at 2.8 hours, what does that really mean? What do I need to do in under 3 hours? I need to be able to stand up my infrastructure. So if I'm running on VMs, whatever infrastructure may be supported, or physicals, make sure that infrastructure is up and running, make sure the operating systems are up and running, instantiate all of my container runtimes, instantiate Kubernetes, make sure all of my repositories are available from my code repositories as well as my image repositories, make sure all my CI/CD tools are available, and then start redeploying all of my applications and make sure that they're up and running. And that starts, when you look at the whole picture, 3 hours starts looking very difficult, which is one of the reasons why I think that obviously DR and recovery into cloud-based platforms is extremely appealing. It's always available. You just have to, make sure your payment method is up to date, and you can start spinning things up. And then it's a matter of bringing your data as well as the different elements of the application up and running, which starts becoming a lot more achievable. What this also meant for us from a design perspective is that orchestration kind of starts becoming important. So what we did from a design standpoint is eliminated from our core design any need to have any specific application agents that would use a traditional streaming method, essentially a copy data kind of method, or and also eliminate any snapshots, because that becomes a management nightmare. In running snapshots every 22 minutes starts becoming a challenge, especially on the side of the graph that's lower. So we approached it with a continuous manner. What that means is that for persistent data, we designed technology that would allow us to continually stream the changes from the applications, on the persistent volumes of the applications on a continuous basis, which allows for extremely low RPOs of about 5 to 10 seconds. But with that, the challenge is you've got a lot of checkpoints, what I'll call checkpoints or possible points that you can recover to if you consider, every 5 to 10 second increments. So you've got a lot of these points to manage. And as a user, you may only be concerned with specific ones. So I may be concerned with a point at every hour, or more importantly, I'm about to push a change out into a production application. I know I can roll that back with Kubernetes. Love Kubernetes for that reason. But how about the persistent data? Well, it'd be really nice if I could tag that checkpoint, essentially bookmark it to say this is special to me because I'm about to put a change out, and if anything goes wrong, I can roll that back. So giving the ability to having both low checkpoints, but also the ability to bookmark specific checkpoints was important for our design. And then along with that was the ordered recovery of applications. It's something that we've traditionally delivered in VM space, but we had to start thinking around what that really means for microservices, for distributed applications. There are still some dependencies. I know Kubernetes has a standard timeout periods built in, which can be changed, but would it be really nice if, for example, my MongoDB came up that's running in a continuous environment, came up in a specific period of time, and only when it was up and running, my higher layer applications essentially came up. So that was an important design consideration, is to try to crack an ordered recovery method for applications as part of our design. So when you consider ordered applications, what comes to mind is also multi-container applications. So by essence, running a lot of microservices or application that is relying on dozens, if not hundreds of little microservices, there is ordered recovery, but also there is consistency that needs to be ensured. So the question that we asked was, how important is data consistency or application consistency? And surprisingly, for a microservices application, it was that over 60 to 70% said, yeah, we do care about having consistency at the entire application level. Now, that could mean, like I said, dozens to hundreds of microservices. Obviously, we don't care about the consistency in the stateless ones, but for the stateful ones, that does become important. So, as well as boot order of that recovery. So from our standpoint, and this is where, from a design standpoint, we really had to think hard and learn more about the cloud native design of applications, and come up with a storage agnostic way of ensuring volume consistency. And I think there's benefits to that. And that's primarily that ideally I'd want to design an application that can run anywhere on whatever storage is available to me on that specific platform. So I could have parts of an application running on-prem. I could have part of it running in a virtual environment. I could have the other part running in one cloud platform, maybe another cloud platform. And that's what the applications are going to look like more and more as they're distributed across multiple clouds and multiple locations. And they'll use multiple services, storage services underneath them. And if we limited awareness or design to a specific storage platform, then the challenge becomes that now is a design consideration. So we had to design a method where we could ensure consistency across all of those volumes, all of those parts of the application, specifically the persistent data, regardless of where where it's living and bring it to a specific point in time. So from a recovery standpoint, the benefit from that design, would be would be that different applications would be able to ensure that they come up to the same point in time. Then I don't have to deal with rolling back certain parts of the application, rolling forward other parts of the application to get it consistent. So that was an important aspect. The second design element was the entire application. So with consistency, the driving factor was the entire application. So from our standpoint, what that meant was looking at all the elements. So obviously the stateful sets, the stateful parts of the applications, but also the stateless components. So the services, the config maps, the deployment templates, bringing up all the elements of that application along with the persistent parts so that we can, so that entire application can be recovered as a whole. And that's been, from our design standpoint, pretty heavy lift, just because of the variety of Kubernetes applications that we get, the different areas in which the important data can reside. Some can be residing within secrets, others can be residing within, let's say, within Helm installer. How do we bring all of that together along with the persistent data so that when a business says recover that application, everything else is recovered along with that? So there's a lot of work, and I think this is an area that we're going to continue evolving in and growing as the landscape changes as well. And then we introduced a concept from our 10 years of experience protecting virtual environments, of really this concept called virtual protection groups, which would be a superset here to the various artifacts models that are available within Kubernetes. So putting multiple deployments, putting multiple stateful sets, putting multiple daemon sets into one logical protection group so that entire entity is treated as one. So we created a superset, if you will, from a design standpoint that is A, environmentally aware of what the specific Kubernetes components are, but B, can give you a set that incorporates all of this. And so this is learning from 10 years of experience that we have, kind of bringing the best of breed of that and applying it to cloud native technologies. And from a design perspective, that for us has been another challenge that we had to overcome, because it's easy to tag or capture a VM. It's a thing, it's a state, but within Kubernetes applications, there are a lot of them. They're used in different manners. So being able to identify all of those and ensure you can capture everything has been obviously a heavy lift from our standpoint, but it's nonetheless important. So when we focus, let's shift a little bit of focus from design of the back end of the application, recognizing the environment. The next question in the survey that was interesting is orchestration of this. So you've got it, you've captured it, you've ideally identified all the elements of the application that need to be protected, but now something bad happens, and we want to be able to recover that and perform operations of it. How's the orchestration? How important is the orchestration? And unsurprisingly, this was by majority said, yeah, this is definitely has importance to them from an orchestration standpoint, because I think this is one of the areas that Kubernetes itself has to grow and start providing some of the traditional enterprise thinking of orchestration for backup, recovery, etc. This is an area that we had to really tap on our other side of the house that has been dealing with orchestration and build some of the orchestration components in there. And we took 3 completely new approaches that we traditionally have not used in our traditional VM spaces at all. And the first of it was data protection as code. We call it data protection as code. And what we mean by this is, rather than us going out and trying to identify all the different components of the application that need to be protected, put the onus on more of a DevOps centric personality or persona. What I mean by that is if I'm a DevOps engineer, I know better than anybody else what needs to be done with this application. There's certain SLAs that need to be met. So as I'm deploying this application to my enterprise's requirements, it'd be fairly easy for me to say, yeah, I would like this protected. So what we essentially did was tap on annotations in YAML deployment, declarative deployment templates, and added a new annotation called VPG. It goes back to that virtual protection group I talked about. And I can push this deployment that I'm giving you an example of into a specific group. So I can say, hey, this is my test group, and I want you to ensure that this is bundled with the rest of the apps and objects and stateful daemon sets that I am going to annotate in the same manner. So what annotations allowed us to do is really push the onus on the front end rather than taking this sledgehammer approach of everything needs to be protected, which drives up cost, it drives up management, and it drives up infrastructure network requirements along with it as well. So with data protection as code, it's as simple as, I've got a deployment, I annotate it if I want it to be in a specific group, and I can annotate it. I can remove that annotation, redeploy, and voila, I'm out of that. So that allowed us to really fast track integration into for orchestration purposes. The other part, which unanimously has been accepted by a lot of customers I've talked to in this area, has been APIs. Everybody wants to use kubectl. Yeah, that's the basic method of operating an environment. So we provided an API extension rather than having another GUI, another set of commands, another set of ways to learn to manage the protection of an application in the Kubernetes environment. We essentially extended the API, which given any other platform, it would have been very hard to do, but the extensibility of Kubernetes just made this super simple for us to employ. And then comes the configuration itself of the components of the application. Again, why not take a cloud native approach and do everything using a declarative configuration? So that's another approach that we put into our core design, is that anything that we do in this application will be declarative. We will not have any funky little config files that are sitting somewhere in a directory that need to be touched, edited, etc. Everything managed in a declarative manner, which I think appeals to that persona as well from a DevOps. So that gives us kind of a overarching view. But if we peel the onion back a little more, dig a few layers deeper, we started looking at specific feature importance. And so what features did the respondents want in the capabilities? An important note on this is, multiple choices were allowed. So unsurprisingly, multi-cloud support. This goes in line with the promise with Kubernetes and container-based applications. I should really have that portability. I should be able to run it on my laptop and run it the same way in one cloud platform, another cloud platform, on-prem. Pick your flavor of upstream Kubernetes, and you should be able to run it on that platform. So multi-cloud support was one of the top features. Access to APIs, again, unsurprisingly, one of the top requirements in terms of feature capabilities. And what they were less concerned was about is policy engines or having a specific GUI for management, primarily because we want to build protection of applications just as we would the deployment of applications. It should be part of our app deployment CI/CD flows, and certain things should just happen when applications get pushed or new applications get brought into production. So this made a lot of sense to us, and which is why one of the reasons I talked about the previous design element was very important for us to provide an extensibility for the API as well as YAML configuration. And then with that, it was about going native with the application. So the one thing that we wanted to avoid was let's say from from an engineer standpoint and as being a huge supporter of cloud native is to design an application outside of the cloud native approach of the design elements for applications. What I mean by that is the last thing is I want to have a Windows server sitting somewhere with a backup application that can essentially back up my Kubernetes or pull my Kubernetes. It's moving forward. I don't want to be moving backward by putting a monolithic application on the side just to be able to protect an environment. The same kind of goes with any hardware-based approaches. We just think it's too restrictive, especially it breaks the flexibility. So from our standpoint, we wanted to have a fully Kubernetes native application, which means it's installed on Kubernetes. It's declarative. It has a choose your option, whether you're doing it via declarative files or whether you're doing it with Helm. But provide that as a method of installing the application. And then being platform independent was important. There are way too many variations out there in terms of the choices we make for hardware, the choices we make for platform, the choices we make for storage, the choices we make for operating systems. We've got different reasons to do that in different applications. So we wanted to ensure that that was platform independent, and going with a Kubernetes native application was, alleviated a lot of those challenges and those intricacies and interdependencies for us. And then there was scaling with the environment. So, being in this industry for a long time, what I've always kind of found frustrating is you've got production running on one side, and then you've got all the side elements. So one of them could be, protection. And as you scale production, which you're planning for, and it's part of the growth cycle, capacity planning cycle, and somebody the last minute realized, oh yeah, we can't do that because we got to spend X on growing the environment that's back up, and now we've got a dependency. So scaling with the environment was important, whether you're scaling up, nodes are becoming more powerful, or if you're scaling out by growing the cluster sizes, we wanted to be able to scale along with that and not hamper, again, a design element of a good Kubernetes application. So what we ended up, when we put all these design elements together, was essentially a very simple application. We have a manager, which is essentially a stateful pod that runs within a cluster. Only one instance is really required, and it's a point for management. It's a point for all the brains on the operation. And then we've essentially got these workers that do the heavy lifting. We call them the replication engines that own the copies of the persistent data, that own the copies of the continuous I/O that flows between applications, and owns the journaling function, essentially providing the continuous backup and the continuous replication. And these are the replication engines. And that's a daemon set that runs on every node. And again, beauty of Kubernetes there, we don't have to manage it. We just tell Kubernetes, here's the daemon set, and here are all of its requirements, and Kubernetes goes ahead and makes sure that's always available. It could be deployed in one cluster, it could be deployed in another cluster. And we try to cut down a lot of traditional components that you would find in, say, an outside approach in order to protect this. It makes it super lightweight, and it grows with the cluster. If your nodes grow up and scale up, then the ZRE components, that's stateful daemon sets, grow with it. If you scale out your cluster with a lot more nodes, then obviously you'll get a lot more of these worker nodes doing the protection, the replication work within the cluster or across the cluster. So a really simple architecture model is what we ended up with. And then I generically refer to it as cluster 1 and cluster 2 in this diagram, because the idea is it shouldn't matter where that cluster is running, whether that's a Kubernetes as a service master from one of the cloud providers out there, whether it's your own flavor that you've picked on-prem, whether it's running on physicals or it's running on virtuals, pick your hypervisor. It shouldn't really matter to us as long as we can recognize what are the different pods that you're deploying that you need protected, and identify the persistent data behind it that needs to be protected. Now, we did introduce a GUI for one area, and this is where I think a GUI is useful. I'm not one to use the Kubernetes dashboard personally for the command line, but from a reporting standpoint, when I need to provide a dashboard to show how things are at a quick glance, this is where we kind of followed what we have learned over the last 10 years, what our VM side of the house customers really like. And that's giving a quick dashboard, one screen to show how is all my protection, where is it going from, where is it going to, how many stateful sets, how many deployment services, config maps I'm protecting, what's my history, essentially what's my RPO, history of RPOs that I'm maintaining, and then what's my running RPO that I can achieve, set SLAs for them, trigger alerts, etc. So we're going to build more as we go along to be able to feed Prometheus, for example. But as a starting point, it's pretty easy for us to take what we had the other side of the house and repurpose it for cloud native application. Another interesting survey question that we asked was around skill sets. So this is obviously important. This is important for a lot of organizations, is getting the right skill sets. And for those of you who attended KubeCon virtual this year, and then there was an entire job board, so I was pretty amused to kind of see that and the number of postings that are out there for the skills in this area. And that's obviously a challenge that that a lot of organizations have, is folks that can understand the needs of an enterprise, but also understand the cloud native way of designing applications and what would be needed in there. So to that end, I mean, we can't fix the people problem, but we're trying to do the best that we can. We make all of our material available online on Zerto.com. It has a lot of material on how we're designing the application, what we're doing. And as part of our KubeCon, this is the first time we attended KubeCon this year, virtual, we introduced a hands-on lab. We're giving a customer's ability, or anybody actually, ability to sign on and run and test what our beta product looks like in a live Kubernetes environment. It's running on a cloud platform. We're paying for it. They don't have to worry about standing up a separate Kubernetes test environment and having to go through all of the infrastructure and security and network concerns and requirements before getting the environment up and running. So we've got that controlled, and anybody can essentially sign on to MyZerto and do the lab. We also have a tech preview that we're downloading. So from our standpoint, the product to beta right now, we're getting a lot of customers, a lot of partners, a lot of tech partners as well, which includes the cloud vendors kicking the tires and giving us feedback. But from a design element standpoint, and anybody's welcome to go to Zerto.com and download it. But from a product and design standpoint, it's been an interesting journey to take what the business side is expecting and what enterprise customers are expecting their future to be within the next 12 to 24 months around cloud native applications, around Kubernetes, really understanding what those requirements are for those applications, and then trying to design a new platform. And then the approach that we're pretty pleased with is designing a cloud native application for cloud native applications versus having to force fit a legacy application, which comes with a lot of baggage, if you will, in order to provide resiliency, backup protection for these applications. And the value at the end of the day, I think, is pretty simple, which is if we can make it easier for you to get your application to production sooner by checking off all the governance marks, requirements. So is backup covered? Is DR covered? Can you recover the application in the event of a loss, whether it's local or regional? If we can check those boxes and help you get a cloud native application out, that's kind of what we're aiming for. So it's been an interesting journey incorporating cloud native methods into traditional application approaches, but it's one where we've learned a lot. So hopefully been able to share some of our design elements, some of what we considered in order to design ours. And like I said, the ESG report is available. We sponsored it. You can get it from Zerto.com. And if you are interested in looking at the rest of the survey questions for which there were plenty anyways. So thank you, and stop there and see if anybody has any questions.
Great, thank you so much. Everyone with questions, go ahead and pop them into the Q&A tab at the bottom of the screen. Those will populate and we can get to your questions.
Libby, I don't think we have any questions. So,
very clear.
Yeah, it's either very clear or it confused everybody.
All right. Well, is there anything else you want to cover in the time we have left?
No, I would just say, go to Zerta.com, and we're going to hopefully GA a product next year. And it's been a tremendous support from the CNC community to get us to this point. So look forward to working with this community.
Awesome. Well, thanks so much for a great presentation, and we will go ahead and wrap it up. Thank you everyone for joining us today. The webinar recording and slides will be up online on the website later today, and we look forward to seeing you at another CNCF webinar soon. Everybody have a great day. Bye.